Alright, this is a video review for Unit 4. Unit 4 covered linear equations, how to solve and graph x and y intercepts, how to find the rate of change or slope, how to graph a line, how to put a line into slope-intercept form, and how to graph an inequality. Throughout the video I will ask you questions to help you study for the Unit 4 assessment. After each question I want you to pause the video so you have time to think about the question that was asked and figure out the answer, and then once you think you're ready you can hit play again. Okay, so the first question I want to ask is, what is a linear equation? So at this time pause the video, think about what you think a linear equation is first, and then go ahead and press play when you're ready. A linear equation is an equation where no exponent can be greater than 1. You cannot multiply x and y together, and you cannot have a variable in the denominator. So let's look at all of these 9 equations here and think about which of these are linear equations. So pause the video again, point to which ones you think are linear equations, and when you think you've got them all, press play again. The 5 equations in the blue rectangle, those are all linear equations. For all those equations, you do not have an exponent that's greater than 1. You are also not multiplying x and y together. So the ones that are not linear equations, this one, x cubed, because 3 is greater than 1, my exponent is greater than 1. X squared, 2 is greater than 1. And then this equation here, you're multiplying x and y together. And here you have a variable in the denominator. I could also multiply both sides by x to get x out of the denominator, but then on the left I'd be multiplying my variables together. So that is why those 4 are not linear equations. How can you tell from a table if your data is linear? So I have an x and y column. These are my x values, these are my y values. These are 3 ordered pairs. And if I look at the change in x from 1 to 4 and from 4 to 7, the change is a positive 3. So I add 3 from 1 to 4, and I add 3 from 4 to 7. If I look at the change in y from 5 to 9 and 9 to 13, I add 4 each time as well. So because my rate of change, or the change in y and the change in x is the same throughout my data, this is a linear equation. Now we have done examples where I can add a fourth point, ordered pair here, 13 and 21, and when I look at the change from 7 to 13, it's not adding 3 anymore, it's now adding 6. If I look at the change from 13 to 21, I'm not adding 4, I'm adding 8 now. So some people would look at that data and say that because the rate of change is not the same throughout, that it would not be linear. However, if I look at 8 over 6, okay, 8 is my change in y, 6 is my change in x, and if I divide both numbers by 2, I end up with 4 over 3. 4 over 3. Okay, so since the simplified form of the change in y over the change in x is the same as what I originally started with, this is indeed a linear equation. What is an x-intercept? So pause the video, think about what an x-intercept is first, and then press play when you're ready. An x-intercept is where the line crosses the x-axis. So this red circle here, this point in the middle of that red circle is 3, 0, so that is the x-intercept. What is a y-intercept? So again, pause the video, think about what a y-intercept is first, then press play. A y-intercept is where the line crosses the y-axis. So that red circle, the point in the middle, that's 0, 4, so 0, 4 is the y-intercept. How do you find an x-intercept? So pause the video, think about how you would do this first. Alright, so let's say we have the equation 4x plus 2y equals 8. If you're thinking about what an x-intercept is, you're on the x-axis, and when you're on the x-axis, your y value is 0. So you're going to set y equal to 0 in the equation above and solve for x. So I have 4x plus 2 times 0, which is what I'm substituting in for y, equals 8. 2 times 0 is 0, so that goes away, and you're left with 4x equals 8. You divide both sides by 4, you get x equals 2. So your x-intercept is 2, 0. How do you find the y-intercept? So now that we just talked about the x-intercept, pause the video, think about how you would go about solving for the y-intercept. Let's say we have the same equation as before. So this time, if you're solving for the y-intercept, that means you're on the y-axis, and x is 0. So you're going to set x equal to 0 and solve for y. So when I plug in x for 0, 4 times 0 plus 2y equals 8. 4 times 0 is 0. So that goes away, and you're left with 2y equals 8. You divide both sides by 2, and y equals 4. So your y-intercept is 0, 4. You can actually graph a line using the x and y intercepts. So how do you do that? Okay, so this is the equation I had before. I found out that the x-intercept was 2, 0, and then the y-intercept was 0, 4. So if I want to graph this line, I'm going to go to the x-intercept, which is 2, 0, which is right here, and I'm going to plot that point. And then I'm going to plot my y-intercept of 0, 4, which is this point right there. And then what I'm going to do is connect those 2 points, okay, to form your line. And then I'll put the little arrows so that it's a line. And that is how you graph a line using the x and y intercepts. Okay. What is rate of change? Well, we kind of already talked about that when we talked about a linear, using a table and seeing it's linear. Okay, but to yourself, pause the video, think about what you think rate of change is. And then when you're ready, press play. Rate of change is the change in y over the change in x. Rate of change is also synonymous with the word slope. Okay, so slope, if someone asks you what is the rate of change, they are asking you what is the slope, because they are the same thing. Okay, you might also have heard slope is the same as rise over run, and more you look at rise over run more when you're looking at a graph. So let's find the rate of change, or slope. Like I said, they go hand in hand between the 2 points. Before I show you how to do it, you look at those 2 points and you think about how you would find the slope or the rate of change between those 2 points. So pause the video, think about it, and then press play. Rate of change between 2 points, okay, you can make a table like we did before. Okay, the table, x on the left, y on the right. Look at the change from, in your x values, from 3 to 4 is a positive 1. What is the change in y from negative 2 to negative 4? It's a negative 2. So your rate of change, right, is the change in y over the change in x. So negative 2 over a positive 1, which is negative 2. So your slope, your rate of change, is negative 2. If you're thinking about rise over run, okay, since the top number is your rise, that's what you would go down 2, and your bottom number is 1, and you would run 1. Alright, how do you do it given a graph though? So here, if I look at this, can you identify which is your x-intercept, where your x-intercept is? Your x-intercept is right here. Can you identify where your y-intercept is? That's right here. Okay, so from the y-intercept to the x-intercept, I'm counting how far my rise was. So I go 1, 2, 3, 4. My rise ends up being going down 4. My run, 1, 2, 3. I ran 3. So my rise down 4 over my run, which is 3. So my slope, or my rate of change, is negative 4 over 3. Alright, slope-intercept form. Think about what a slope-intercept form equation looks like. Pause the video, think about it first, and then press play. Slope-intercept form is in the form y equals mx plus b, where m is your slope, so the number in front of your x is your slope or your rate of change or your rise over run, and then b is your y-intercept. So if I'm looking at the equation y equals 3x plus 2, think about what is your y-intercept and what is the slope in that equation. So pause the video, think about it first, and then press play. So your y-intercept, okay, the second number, the b, okay, is 2, or if you're plotting the y-intercept, it would be 0, 2. What is your slope? That is the number in front of the x, okay, that's your 3. So 3 over 1, the rise over run, or 3 would be your slope. So how do we graph this line? Okay, so let me go back. Alright, so here's my equation here, y equals 3x plus 2. So we already talked about how 2, this number right here, was my y-intercept. So I'm going to plot the point 0, 2, and then this number in front, the 3 is my slope, the rise over run, so I'm going to put 3 over 1, means from this point I'm going to rise 3, 1, 2, 3, and run 1. Okay, I can do the opposite direction from this point here and go down 3 and then 1 to the left as well, so I have my 3 points. Okay, and then now I will connect these points. There you go. Put the arrows on my line, and I have my graphed line right there. Okay. What if the equation, though, is not in slope-intercept form? So if it's not, like the equation we dealt with before, 4x plus 2y equals 8, you do not have y on a side by itself and mx plus b on the other side. So we have to put this equation into slope-intercept form. So here's the equation. So pause the video, think about how you would move that equation around so that it was y on one side by itself and x and your mx plus b on the other side. Once you think you know what you're doing, go ahead and press play. So the first step you would do, since you're trying to get y on a side by itself, you're trying to get this right here, this variable, okay, the y, by itself. If you're trying to get that on a side by itself, we do not want this positive 4x on the same side. So to get rid of that 4x, we are going to subtract 4x on both sides. What you do to one side, you have to do to the other side. So that's going to leave us with 2y now on the left side and negative 4x plus 8 on the right side. You can't combine these two because 8 does not have a variable x with it. Okay, so now we're almost at y being by itself, except you have this, you're multiplying by 2 in front of it. So in order to get rid of the multiplying by 2, you are going to divide by 2. But once you do to one side, so I divided by 2, you have to do to the other side. And you have to divide everything by 2 on the right side. So negative 4 divided by 2 and 8 divided by 2. And that leaves us with y on the left, negative 2x on the right, plus 4. So now this is in slope-intercept form, and now we can go and graph this equation. Okay, so here's my equation. Y equals negative 2x plus 4. Remember from before, this is my y-intercept, so I'm going to plot 1, 2, 3, 0, 4 as my y-intercept, and here's my slope, the number in front of the x, negative 2 over 1, rise over run. So from this point, since my rise is negative 2, I'm going to go down 2 and run 1. Down 2 and run 1. So now I can plot, graph my line. There you go. Put my arrows have now graphed that equation, even though it started off not in slope-intercept form. Alright, so now we already graphed that line. Okay, but how do you graph an inequality? So what makes this equation right here, or what makes this an inequality? Well, you no longer have an equal sign in between. This is a less than or equal to symbol. So this is what makes it an inequality. The difference between an equation and an inequality is an inequality doesn't have an equal sign. So how do I graph this? You still need to put this in slope-intercept form like before. Okay, so here's my inequality. 4x plus 2y is less than or equal to 8. So just like before, if we have to put it in slope-intercept form, you have to subtract 4x on both sides to get 2y by itself. We're left with 2y on the left, negative 4x plus 8 on the right. Now, y is almost by itself here, but we're multiplying by 2, so you divide both sides by 2, and remember to divide everything on the right by 2 as well. And so now we're left with y is less than or equal to negative 2x plus 4. Now, if you remember from inequalities before, don't forget, if you divide or multiply by a negative, you have to flip this inequality. Since we only divided by a positive number, our inequality stayed the same. So now we have our inequality that's in slope-intercept form. Okay, now we can graph the inequality. This graph on the left is the inequality that we put into slope-intercept form. Okay, my 4, remember, was my y-intercept, so I go up 1, 2, 3, 4. Here's my slope, negative 2. I'm going to put that over 1, so rise over run. You are going to go down 2 and run 1, down 2 and run 1. Let's connect my graph. But before I do that, this is an inequality. And so there's two things that are different than just a normal equation. Before I connect these, I have to look at this sign. It's less than or equal to. Since it's including the equal to part underneath this less than sign, then you can go ahead and put a solid line through your points. If this part right here, the equal to, wasn't there, then you would have to do something different, and we'll go over that in that example over here. Okay, so now we connected our line. It's a solid line because it's less than or equal to. And the last part is now we have to shade on my graph. Since this is less than this line, you want below the line. Below the line would be here. Above the line would be this region up here. So since you want less than the line, you want below the line, so you will shade everything below that line. So this part right here is all the solutions that work for this inequality. Let's come over here and now discuss what would happen if it's not equal to. Okay, this is the same equation, so my y-intercept is still 4, so I'm plotting the 4. I still go down 2 over 1 for my slope. Down 2 over 1. Okay, so now since it doesn't include the equal sign, okay, I'm not going to have a solid line because you don't want to include the line. Instead, it's going to be a dashed line, dotted line. Okay, so that's the difference between when you use a solid line like this one, because it was also equal to, versus just an inequality where it doesn't have the equal to. So here this line was dotted. Okay, and now in this inequality, where are we going to shade? Well, here's my line, and this symbol here means greater than, so we want greater than this line. Well, if I'm here, I'm below the line. If I'm here, I'm above the line, and since I want greater than, I will shade the part that is above that line. And that is how you graph an inequality. So this Unit 4 video review is a quick summary of everything that we've done in the unit. It is It'd be very good if you watched this and understood everything in the video, but remember that this is not the only thing you should watch in order to study for your assessment. You also need to go back and make sure you can do practice problems throughout the unit as well. Okay, well, good luck studying, and I hope you do well.